good. I'm going to try and project my voice more so it comes through. Okay, start. Welcome, class, and stop. Do it all again. Okay, start. Welcome, everyone, to today's lab. We're going to be going over some of the topics we covered in lecture. Today, we're going to be covering classes and objects, and just a simple example revolving around the keywords that we discussed. Those keywords being class, object, constructor, method, field, state, and behavior, as we saw previously. Here in lab, the main goal is to demonstrate some of the logic that we've done and give a reference to some code to make it more real. Today, I will be using Atom as my text editor, and the language that we'll use to demonstrate this abstract idea will be Java. I chose Java because it's statically typed and very neatly written code is easy to convey a thought as well as strong in the way that it portrays things. I will be using Java as we move forward, but I will update with more languages as I see fit. Okay, without further ado, let's start lab. Here you can see I have my Atom text editor open on the right here with our prompt. We also have a tab open here on the left that will be useful in a second. So our prompt is to write a class based off of a random word. It should have a constructor, a logical field, and a logical method. So what I mean by that is um, it should have a way of being created as well as some field or data that represents the object that we're trying to show, as well as a method, something to define the behavior of that object. And when it's done, we're going to also write an example of how the, sorry, a little typo, sorry. There we go. We're going to demonstrate the use of the class by instantiating some objects and manipulating them. We'll just do that in the main method to show how it works, and we will see later examples of more classes as we go forward. So the way that I usually handle the random words is I generate 5 or 10, and then I choose one of them that work, because sometimes you can get some words that can make it kind of difficult. So let's do it. We're going to do it live. So the words we got was weak, goofy, difficult, touch, and cow. I feel like cow is the easiest one here, but let's do weak. Weak is a very good one. So we're going to open up a new file and we'll name it with a capital W, weak.java, and we can get going. So we want to have a class. The class's name is going to be the same as the file name as we usually do in Java. And we want to show that it has a constructor as well as a field and a method. So the syntax for the constructor will be public, the name of our class, and the parameters for that constructor. We don't know what we want to add, so we're going to leave a comment. Add initial setup. So we know to do that later. The next we want to work on is adding a field. So what is a common field we could have for a week? Let's have a private integer for the number of days, let's say, in a week. Here we'll set it to 7, and we might manipulate that further later. What other fields would be nice? I know the prompt only says 1, but we can add as many as we like. Um, let's have a variable of an array of strings, which are the names of these days. So name of days, leave this one not filled in. And you know what? Let's make our code more modular. We could have maybe a week in a different place. Maybe a lunar week only has 5 days and they go by different names. So we'll make it more modular. So what we want to take in is our number of days as well as our array of name of days. And we want to assign them appropriately. Important to note that I use the this keyword here. This keyword is not necessary to be used except pretty much in this case and one other case we may see later. It's because we end up with a shadow assignment. If I don't use the this operator, for example, and I use number of days equals, name of days equals name of days, this would refer to the parameter up here twice. We would be assigning the parameter to the parameter, effectively doing nothing. So to avoid that, we explicitly say, for this object, assign those days there. Okay, cool. So a common logical method would be getters and setters. These are just common methods that allow you to get private fields, as you see up here, that are going to be hidden and expose them in a safe way. Something we'll talk about further known as encapsulation. But if we're going to set them up in our constructor, we should have probably getters and setters. So let's just write those in. Let's just get a day. Let's get day at. And this will take in an index, and we can give them back the index of days. So let's say we just had 25 days. They could put that in, and then we can give them back a day to refer to it. So 25 is obviously larger than 7 in this case. We're assuming for our normal week. So we're going to say if the index is larger than our number of days. See, we didn't need to use the this time. We can reassign our index to the mod, or the remainder of the number of days. So now we have a number bounded between 0 and the number of days, no matter how large the number is. And then from there, we can return out of the names array the index that we were given once it's been checked. So we can get day at, that's a little bit more complicated of a getter. We could say, oh, and I forgot my return type, I apologize. So we're going to return a string in this case. We can get how far, and we're going to give in 2 days. So let's say our first day, we'll just name it day 1 for now. No, let's name it first day. I don't like using numbers in my variable names. We can be more descriptive than that. But however you code it, as long as you keep it consistent, is always important. So we'll have first day and second day. So maybe you want to see how far away one day is from another, especially if we're using a funky different way of representing a week. So we can now say we need to find a way of getting our day and then counting up to that point. So we want to take the return value of a method that we'll write. So get day index, and we'll put in first day. And I'm doing all this on the fly, just coming up with it, just to demonstrate that this is how we can create a class. We just took two fields and now we're writing two methods, maybe a third helper method, to demonstrate some of the functionality that we can do with the class. And then we're going to have a main method that will run some examples as the prompt says. So we should be able to get the day index of the second day. And then I want to get the absolute value. Because if they put one day that's before the other, I don't want it to return negative numbers. That would be a little confusing. So we'll just absolute value to show just distance. So let's write this helper method, which is going to take in a day name and it's going to return that position in the array. So we can just going to simply loop through the array of day names. So we won't call it day names. We'll just say name out of name of days. And we want to return the index. So if we do it this way, it's harder to keep track of the index. So we'll just keep track of our own, just to keep it simple. So if the name is what we're looking for, don't worry about the Java code too much. Just read it along as I write it. And we are looking for day name. We're going to return whatever our I is at that point. If not, we'll just continue iterating forward. Perfect. This formatting is a little off to me, so I'm just going to make sure everything is right. I think our if statement's a little too indented. There we go. That all looks good to me. So it's going to loop through and eventually get to it, and we're going to have a return statement of -1. If for whatever reason we exit the loop, we shouldn't if we're looking for days that actually exist. But if we end up exiting the loop, we know that the day does not exist. We could leave a note for ourselves. We're going to extend this further to throw an error or an exception so our code stays consistent. Okay, so this should do what we're looking for, and it takes care of a lot of the code. So now all we're going to do next is work on writing that main method. The main method is going to be that last little paragraph. I'll write out the main, where we're going to demonstrate some of the functionality of this class. Oh, excuse me. I think I can just do that. Yep, and it does it for me. That's great. So first thing we want to do is we want to make an instance of a week. So we're going to say week, and we're going to use our normal uh, week. So let's just call it normal equals new week. And our constructor is going to want two things, the number of the days and an array of those days. So let's start on Sunday. Then we can go to Monday. It's going to take me a moment to type all these out. Tuesday. Wednesday. Thursday. Friday. Saturday. And then we finally have, no, I think I started on Sunday. Perfect. So that should be all 7. And now we want to use some of our methods. So let's find out what would be the, so we have to reference our week's name, which is normal. And we're going to get our day at, and we're going to give it an index. So get our day at, let's say, the 100th day. Let's see what that would output. And then let's do another print statement, and let's print out that other method we use, how far. So let's see how far Monday is from Friday. Let's see how long our work week is. So Monday to Friday. And let's add a quick prefix to this print statement so it makes a little bit more sense. The 100th day encountered is, there we go. So we showed how we used it. On this first line, we're instantiating it, giving it the information it wants in its only constructor. But we could have had multiple constructors. Then we print out uses of our methods. So getting the 100th day that we're going to encounter, as well as the work week, the average work week, average work week length. And we ran the code for that. We're going to run the code for that. I apologize. Okay, perfect. So let's save this. You want to save usually more than I was doing, but just for a demonstration, this is simple. And I'm going to bring up my terminal. I am using Windows right now, so I'm using the embedded Linux terminal on the Ubuntu subsystem. So here, I'm already in the directory. You can see that our week is there. So So we're going to use the command javac to compile our file. And if there are any errors, it's going to tell us. So we have an error. It doesn't like the start of the expression. So let's go in and fix that. Okay, moving this back off screen. The start of the expression it did not like. So let's add a new array. See if this fixes it. It did not. It's expecting for the array to close. Okay, excuse me while I debug this. Okay, pulling our terminal back up. Let's see if this makes it better. Nope, made it worse. And we'll go and run our code. For some reason, the string array is really not happy. So we're going to save it to a separate variable. We'll call it names. And move that up. Drop the names in there. And there it goes, it works. So it just wasn't happy with the type conversion, which is definitely, it's important that we make a note of bugs that we end up getting. So type conversion error occurred. Just so we know that that caused a issue in what we thought would work. So let's clear off all of this other code in our command line, and let's make sure that we are compiled. Cool. Now we're going to run Java week and see what outputs. So we see that two things got outputted. The 100th day would be Tuesday. So starting on Sunday, if you did the remainder of 7 out of 100, you would end up getting, let's find out. Let's get a calculator. So checking our calculator, 100 divided by 7 gives you this number, and gives you that as a remainder. So we do 14 times 7, and we can see it leaves off 2 days. So 2 days, that would be Sunday to Monday, and then Monday to Tuesday. Perfectly correct. And then we see that the average work week day length is 4. So we see that our math was a little off, and we should fix that. So it would have gotten Monday, which would have been index 1, and then it would have gotten Friday, which would have been index 5, I believe, which would give 4. So we can solve that. I believe it just needs an extra day to include where it was. go ahead and run it again. So we have to recompile. Hopefully no errors. Great. And then we run it again. And we actually got lower. Whoops. Okay, we just have to fix that error, and then we can go and compile again and run it. And we see that the length is now 5, which is correct. So we're going to write down a note on that bug saying proper bounds needed to include, well, need to be included, let's say. There we go. So we'll save that. And this is our code. I will make sure that this and the prompt is up on a GitHub, which will be linked in the video. And if you have any questions on this, feel free to message me and we can further flesh this out. Thank you for participating in lab this week. And next week, we'll be working on that encapsulation problem that we had, saying why do we have private here and public here and etc. And we'll have another challenge or prompt along with it. I hope you have a great day and keep on coding and stop.